quicker on this. Let's get to this number 2. There it is. Not very good. God, this thing is driving me crazy. There it is. So number 2, we're looking at this. Yeah.
Got roll.
Hey, it was good. Yeah. Yell at me at the store sometime. Thanks.
Oh, yeah. Come on in.
Yeah. So the second part of this problem. Whoops. Let me see if I got this thing started. I might have done that plenty of times. Yep. We're wanting to compare a typical solar PV array, its electricity, all right, and we're given, but I have a heck of a time with this thing. Not happy. Here we go. We're given that thing makes 2730, and I know that because I had the pleasure of having a project at the university to audit a bunch of their green energy projects over about a 3-year period average, making that amount of electricity a year. Beautiful building, that Lifelong Learning Center. And on the roof there's 10 solar panels put in as part of the CRELF initiative, and we'll go there some other time. But it's got a measurement device on it, and averaged making that over about a 2.5-year period of time. So that's about electricity it produces. And they have net metering. Anything they produce that they're not using goes back to them, so they get all that. So the question asks us, 1 day's worth of the solar system is equal to one. Oh, I just wrote it wrong. Can I erase it? Boy, I had trouble getting up there to do that part. Sorry. There it is. So this coal car equals to how many, that's a number, of Todd Systems, it's goofy saying it this way, production per day. Okay, so that system produces 2730 kilowatt hours. I didn't put the bottom down there, did I? I'm already getting goofed up. Per year, pretty simple to know how much it does per day, right? Okay. So that thing makes 7.48 kilowatt hours per day. And that's pretty typical of a solar system in Montana and all over the place. Yeah, they'll vary because of the climate, but now I've got myself to the end here. Gosh, how do I do this? Well, here. Yeah. I'm better with my own CAD. I should have brought it. 7.48, or around 7.5 a day, okay? That isn't what we want to know. We want to know if in 1 day that Todd system makes it, our rail car can make this much in a day. Todd system can make 7.48 kilowatt hours per day. the ratio of those two will give you how many Todd systems that thing could do. 28,326 systems. And that 10 solar panel array and the amount of electricity that system makes is typical of what's around Missoula, okay? I don't know them all. But I know there's 12 panel systems, there's 8, there's 10, and their orientation and efficiencies will vary, but that's typical. So for one rail car of coal, to make that electricity from the sun in Missoula, given the efficiencies of that Todd system, you need well over almost 30,000 of those systems for that one rail car of coal. That tells you something. You know, that coal is energy dense, and I know it was covered last class. The density of that coal is a tough nut. That's why it's so valuable to us. It also creates a lot of problems, as we know. The neat thing about the sun, it's going to be around for as long as I am, anyway. And there's not much maintenance on that Todd system. There's quite a bit of maintenance on that boiler, I'll guarantee you, because we have boilers at the mill. I'll guarantee you it's a tough nut. You don't have much sulfur anymore in the coal, but that sulfur gets in with water, with the natural water that's in the coal, and that's another subject, what water does to your systems or to your efficiencies. You got acid, you got sulfuric acid, and it's pretty nasty on the tubes inside that boiler. So a lot of it, and then you got the pollution control devices on there. You got sulfite scrubbers, and they're problematic and all that. Thankfully we got those, because acid rain now is not nearly the issue of coal as it was. So that many systems, that's alarming almost, but hey, everybody in Missoula, I don't know how many houses in Missoula County, I know there's 100,000 people approximately. Let's say 3 to a house, so there's maybe that many dwellings in Missoula, not counting businesses. Yeah, we had all solar systems on them. We'd be producing per day what one rail car of coal is per day. Okay, but you got to know that these boilers are huge and make a lot of electricity. They have to be. They have to. And the advantage is you got centralized. You can spend a lot of money on the controls to make them as right as they can be made. Whereas if you had 28,000 little boilers around homes, how much money can you spend on it? You saw earlier I don't know if you saw the picture of all the smog in London in the old days with the coal. Everybody was burning coal in their homes. No controls. Nothing. Oof there. Okay. Let's go to number 3. You follow that? You guys get there? Okay, let's get to 3 in a hurry here. Whoops. Already got to there. There it goes. Maybe a neater one. Oh. So number 3, we're looking at a wind turbine, right? Generator. We got a 1.5 megawatt turbine. I gave you some useless information that at Judith Gap there's 90 of them. Wind, and you'll get there, is unbelievably coming on in Montana. Last 10 years, the amount of electricity produced from wind has really gone up. There's new systems up around Glacier. There's a new one that they stuck the shovels in the ground late December of last year, when they still knew they were going to get the credit for a big wind farm also down by Billings. I don't remember the name of it, but wind is really coming on. Neat. It's got a lot of advantages, a lot of disadvantages, but a lot of advantages. So we're going to assume it's 30% capacity factor. Who knows what capacity factor is? Did you look that up? It's simply a system's achieved amount or quantity. Oh, come on. Gotta keep losing this thing. do. It's on page, the problem stated 335. It's achieved quantity divided by how much you would achieve at perfect running all the time at full capacity, right? So to find out what this wind turbine on the average achieves, we need to know what it could make running full out. So in a day, and we were there, it's rated at 1.5 megawatts. If it's running at full rating for a full day, it's 1.5 times 24. There it is. Okay. Achieved divided by the full rated full time. Okay. Because wind turbines don't run all the time. When there's no wind, they're not rolling around. Hydroelectric systems, they're not always drawn down. So there's, if they were dry, if the wind turbine was running at the maximum wind the full time, that would be making 1.5 megawatt at the rated wind. And we'll get into that later chapter. Okay, so I lost it again. Relative to this problem, we got 1.5 megawatt running 24 hours per day. Okay, now we've taken a power, that's power, to energy. That's 1.5 times 24. Let's take it times 1,000 kilowatts per megawatt. That gives you how many kilowatt hours can be made out of that system running full time, but at full rating, but capacity factors again 30%, so you only get a little under a third of it. You're getting 10,800 kilowatt hours per day out of that one wind turbine on the average. So it's quite a bit. But those things are 300 feet tall. They're, what's the diameter? They're nearly 300-foot diameter blades. They're majestic. You get a chance to go, ever get to see a wind farm, it's worth it. The summer practicum on a weekend, they usually go over to Jewett Gap, sometimes up to Glacier. And you go up in the wind turbines and whatnot. They're pretty cool. And I think, yeah. Here. So you got 10,800 kilowatt hours per day for one turbine. Our coal car can do 212, isn't that right? I hope the audio's on. I don't know if people can better read this that aren't here. But, what's that? About 20 turbines. That sound right? Okay. So, where have we gotten to? That rail car of coal is equivalent to about 1.5 megawatt turbines electrical production in a day, and equivalent to would we say over 25,000 PV systems. A lot of oomph in that coal. Wind's cool. Wind's free. It's going to blow. It doesn't blow enough in Missoula to pay to put a wind generator in there. I don't, until technology changes. You're not going to put one on your house. You can't afford it. And they wouldn't let you put a tower up anyway, probably. You can sure put a solar panel on your house. That's the neat thing about solar.
You can buy the little personal, the small turbines.
Yeah, you could. And it could make a bunch of electricity for you.
You can maybe turn on the lamp with an LED light bulb.
Oh yeah, yeah. There's people that do those things. Yeah, that's cool.
Yeah.
I'm gonna have the farm Caribbean all the time.
Yeah.
2.5 acres
Yeah.
are always
Yeah.
littered with little turbines.
charging their, their batteries and,
Yeah.
and refrigeration and all
Yeah.
those boats.
Yeah, it's nice, yeah.
But it's always blowing.
So is this class supposed to make you like fossil fuels or?
Well,
I'm just.
the point here is that we've got a tough nut to replace that coal. And a lot of people can't understand, why in the world are we still doing coal? I'll tell you why. Economics. Economics are tied to energy density. And the next class, we're going to look at bioenergy. We're going to look at a car full of wood chips. Well, the wood is not nearly as energy dense. It's okay. And it's got quite a bit of moisture in it, more moisture in it, and you don't have nearly as much in a rail car because its bulk density is so much less. So it's harder to handle. But it's a good source too. Very good. Most disappointed. I was on the sidelines, but when
The university.
the neighborhood was successful shooting down the university boiler, a friend of mine's going, and he teaches a class at this curriculum. I used to work with him at the mill. So eventually people would rather have everybody have a wood stove and have to put their own pollution control on it to replace coal, or do you want a boiler that can replace a lot of electrical usage in the community where you can afford to put the right pollution controls on? They had the bells and whistles planned for that thing. Pretty good. Is there going to be handling issues? Sure, some. Yeah, there can be some fugitive dust. They had plans to mitigate it, but yeah, there's going to be some. There's going to be trucks rolling through this, but holy, you got to go somewhere, in the meantime, till that next thing is found. We'll find that next thing. There's too much money in it. You want to be the one that finds that next thing. The acceptable, renewable technology that can replace a lot of this and and do it economically for the consumer. You're going to be set for life. So good luck. A lot of ideas out there. No, you hear a lot about them. There's a lot. Gosh, I used up a lot of time. Okay. So anyway, a couple of things here worth looking at. When you get these problems in class, do not forget units. Write them down as you solve the problem. And I very much urge you to write down what you're supposed to find and the units and what you're given and the units. I didn't write it all down here. There's some things we're given we didn't need. The number of turbines at the facility in Judith, we didn't need to know that. But that's typical of life. You have a lot of information out there to sort through. You may or may not need, and you got to sort through that. So, okay, thank you. We'll take another pause. It's about blew the whole class on that, huh? Think of any questions you may have as we're going in the pause here, so make sure I've allowed enough time for your questions. And I do want to get to a little bit of the stuff in the text before we get out of here. There it is. Okay. That's a short one.